On the morning of March 20th, 1905, a chief engineer named David Rockwell sat in a chair near the boiler house window of the R.B. Grover Shoe Factory in Brockton, Massachusetts. His wife saw him from the kitchen of their home, which stood about 100 feet from the factory. Rockwell had a first-class engineer's license and 12 years of experience. He was a careful man. His wife would later tell investigators that he had been irritable for days because he was being forced to operate a boiler he did not trust at a pressure it was unequal to. The factory's newer boiler was down for routine maintenance, and Rockwell had been ordered to bring the old backup online. A 17-foot steel cylinder built in 1891 with riveted lap joints that hid their age between overlapping plates of metal. He had lit the coal fire the night before, brought the boiler up slowly, and by early morning it was heating the building for 400 arriving day shift workers. At 7:45, the plant manager called Rockwell's office to report strange noises in the radiators along one wall. Rockwell had just stepped out. His assistant told the manager everything was fine. A few minutes later, the boiler exploded. It rocketed upward through 3 floors and the roof. It struck the factory's elevated water tower on the way out, and the full tank crashed back through the building, collapsing the rear portion of the 4-story structure. The floors pancaked. The walls fell inward. Workers were pinned beneath broken beams and thousands of pounds of shoe manufacturing equipment. Burning coals from the boiler's fire pit showered the wreckage, igniting broken gas lines. 300 windows, blown out by the blast, created a chimney effect that turned the ruins into a furnace hot enough to melt iron pipe. Then, the naphtha exploded. Barrels of volatile industrial solvent stored in a wooden shed behind the boiler house detonated in a second blast, throwing sheets of flame across the debris and driving rescuers back. People half a mile away could hear the screams. 58 people died. 150 were injured. 36 bodies were so badly burned they could never be identified. They were buried together in a common grave at Melrose Cemetery, where the city of Brockton erected a monument that still stands today. David Rockwell's body was found the next day in the boiler house. A charred corpse, a bent watch, 2 rubber heels, and a torn piece of clothing his wife identified as his. He had been sitting near the machine he did not trust when it killed him. The boiler that destroyed the Grover Shoe Factory was not unusual. It was not defective in any way that could be detected by the inspection technology available in 1905. Boiler inspectors who examined the wreckage found a crack in one of its riveted lap joints, hidden between 2 overlapping plates of steel where no inspector could see it. Experts characterized the boiler as old technology with a short remaining service life under high pressure, and then they noted that thousands of identical boilers were in service across the United States at that very moment. If you want to see which machine I cover next, subscribe and drop it in the comments. The steam boiler is the most prolific killing machine in the history of American industry. It killed more workers than the punch press, more passengers than the Titanic, and more soldiers than most battles of the Civil War. And it did it so regularly, so predictably, and for so long that the people who owned the factories and the steamboats that used them came to regard the explosions as ordinary. Factory owners in the 1850s simply assumed their boilers would explode and that they would lose 1 or 2 workers when it happened. Insurance companies built their actuarial tables around the assumption that boiler failure was inevitable. The Hartford Steam Boiler Inspection and Insurance Company, founded in 1866, was conceived at a time when catastrophic boiler explosions were occurring at the rate of 1 every 4 days, not 1 every 4 months, every 4 days. In 1880, the year the American Society of Mechanical Engineers was founded, there were 159 boiler explosions in the United States. In the first decade of ASME, more than 2,000 boilers exploded. From 1880 to 1890, 100,000 boilers were in service across the country, and the explosions kept coming because inspections were rare. Construction standards did not exist, and operating guidelines were essentially voluntary. The boiler was not a machine that occasionally failed. It was a machine that was expected to fail. The only question was when, and how many people would be standing near it when it did. To understand why the boiler was so dangerous, you have to understand what it is and what it does. A steam boiler is a closed vessel that heats water under pressure to produce steam. The steam drives a piston, turns a turbine, or heats a building. The principle is the same one that makes a tea kettle whistle, except that a factory boiler operates at pressures between 40 and 150 pounds per square inch. The vessel contains hundreds of gallons of water. The water is superheated well above its normal boiling point, and the energy stored inside is equivalent to a significant quantity of explosive. When a boiler fails, the pressurized water instantly flashes to steam, expanding to roughly 1,700 times its liquid volume in a fraction of a second. That expansion is the explosion. The steel shell of the boiler becomes shrapnel. The superheated steam and boiling water become the blast wave. The boiler does not burn. It does not detonate like dynamite. It releases stored energy, and the result is indistinguishable from a bomb. Could you imagine standing next to a sealed steel container the size of a small room, knowing that the water inside is being held at temperatures and pressures that would kill you instantly if the metal gave way? If that thought keeps you up at night, let me know in the comments. The ways a boiler could fail were numerous, and for most of the 19th century, they were poorly understood. The most common cause was simple corrosion. Water inside the boiler ate away at the iron or steel plates over time, thinning them until they could no longer contain the internal pressure. But the corrosion was invisible. It formed along the edges of riveted lap joints between overlapping plates where inspectors could not see it. A boiler could pass an external inspection on a Monday and fail on a Tuesday because the flaw that killed it was sandwiched between two layers of metal. This was exactly what happened at the Grover Shoe Factory. The crack was in the lap joint. It had been forming for years. Nobody could see it until the plates separated and the steam came through. Low water level was another killer. If the water inside the boiler dropped below the top of the firebox, the metal overheated. When the feed water pump eventually kicked in and cold water hit the superheated plates, the rapid temperature change could crack the metal or cause the weakened plate to give way under pressure. Engineers who ran boilers understood this risk, and the experienced ones watched their water gauges obsessively. But boilers in the 19th century were often tended by poorly trained workers, sometimes by children, and the gauges themselves were unreliable. A scale buildup on the inside of the boiler could insulate the metal from the water, causing localized overheating even when the water level appeared normal. Mud, sediment, and mineral deposits accumulated on the firebox crown and created hot spots that weakened the metal from the inside out. Then there were the safety valves. Every boiler had one. It was a spring-loaded valve designed to open automatically when the internal pressure exceeded the boiler's rated limit, venting excess steam before the pressure could reach dangerous levels. The safety valve was the last line of defense, and it was routinely defeated. Factory owners who wanted more steam pressure would tighten the spring or add weight to the valve, raising the release point above the boiler's design limit. Steamboat captains racing each other on the Mississippi would tie the safety valve shut with rope or wire to prevent it from venting steam during the race, squeezing every last pound of pressure out of the boiler to gain speed. A steamboat captain named Van, racing to New Orleans on the Lucy Walker in 1844, reportedly forced a slave at gunpoint to throw slabs of fat meat into the boiler's firebox to superheat the steam. The slave threw in the meat and then jumped overboard. The boiler exploded moments later. Over 100 people died. The steamboats were where the carnage was most spectacular and most public. Before the railroads connected the country, steam-powered riverboats were the primary means of long-distance transportation in America. They were also floating bombs. Between 1816 and 1848, 233 boiler explosions occurred on American steamboats. Between 1825 and 1830 alone, 42 explosions killed 273 people. Between 1810 and 1840, nearly 4,000 people died on the Mississippi River from steamboat boiler failures. The deaths were not limited to workers and low-fare passengers. A senator died in an explosion on the Red River. 3 congressmen died in separate blasts on the Ohio River and the Atlantic Ocean. The former mayor of New York City was killed in a boiler explosion aboard the Hudson River steamer Henry Clay in 1852. Mark Twain's brother, Henry Clemens, died from injuries sustained in the Pennsylvania explosion on the Mississippi in 1858. The event haunted Twain for the rest of his life. He wrote about it with the precision of a man who could not stop seeing it. 4 of the 8 boilers exploded with a thunderous crash, he recalled, and the whole forward third of the boat was hoisted toward the sky. Shrieks and groans filled the air. An iron bar had been driven through one man's body. The worst was the Sultana. On April 27, 1865, just weeks after Lee's surrender and Lincoln's assassination, the steamship Sultana was chugging up the Mississippi with more than 2,200 people aboard, most of them Union soldiers just released from Confederate prison camps. The boat's legal capacity was 376 passengers. One of the 4 boilers had been bulging and leaking since New Orleans. The captain, eager to collect the government contract payment of $5 per enlisted man and $8 per officer, ordered a hasty patch rather than waiting 3 to 4 days for a proper repair. The patch was thinner than the original boiler wall. 2 days later, at 3 in the morning, 7 miles north of Memphis, the patched boiler gave way. The failure ruptured 2 more boilers. The Sultana burned to the waterline in 15 minutes. An estimated 1,800 people died, making it the deadliest maritime disaster in United States history, worse than the Titanic by nearly 300 deaths. The nation barely noticed. Newspapers were covering Lincoln's funeral train and the hunt for John Wilkes Booth. But the factory boiler was quieter and more persistent than the steamboat. It did not make headlines unless it killed dozens at once. A factory boiler that exploded and killed 1 or 2 workers was a local story, reported in the town newspaper and forgotten by the following week. The worker's family received nothing. Before workmen's compensation laws appeared in the United States in 1910, the only recourse for an injured worker was a lawsuit against the employer. Employers had 3 legal defenses so reliable they were called the unholy trinity: contributory negligence, the fellow servant rule, and assumption of risk. If the worker was even partly at fault, the claim failed. If a co-worker's action contributed, the employer owed nothing. And if the danger was considered a normal part of the job, which operating a boiler certainly was, the employer was not liable. Only 1 in 8 injured workers ever received compensation through the courts. Factory owners understood the math. It was cheaper to let the boiler explode and fight the lawsuit than to slow down production, lower the pressure, and maintain the equipment. Between 1870 and 1910, there were over 10,000 major explosions inside American factories, and the boiler was responsible for a significant share of them. The people who finally did something about it were not regulators, they were insurance men. In 1854, a boiler at the Fales and Gray Car Works in Hartford, Connecticut exploded, killing 21 workers. The disaster shook the city. A group of Hartford businessmen associated with the use of steam power had already been meeting informally as the Polytechnic Club, discussing matters of science relative to everyday life. With boiler explosions becoming such a central part of everyday life, their conversations kept returning to the same question: why did boilers keep exploding, and could the explosions be prevented? They concluded that the answer was straightforward. Boilers exploded because the pressure inside exceeded the ability of the vessel to contain it. Better materials, better design, and periodic in-service inspections for corrosion and wear would prevent most failures. They so believed in this view that they were willing to put money behind it. In 1866, they founded the Hartford Steam Boiler Inspection and Insurance Company, an organization built on a radical premise: combine insurance with mandatory inspection. The insurance would function as an incentive to inspect, and the inspection would function as a guarantee of safety. It was the first time anyone in America had systematically attempted to prevent boiler explosions rather than simply paying for the damage after they occurred. Hartford's inspectors fanned out across the country, examining boilers, finding cracks, ordering repairs, and building a database of failure modes that no one had ever compiled before. They found boilers with corroded plates, leaking joints, safety valves that had been tampered with, water gauges that read incorrectly, and firebox crowns coated in scale so thick the metal was glowing red behind it. They published their findings in a quarterly journal called The Locomotive, which began in 1867 and is still published today. Year after year, the inspectors documented the same problems. Year after year, the boilers kept exploding. Because Hartford could only inspect the boilers of its own customers, there was no law requiring anyone else to inspect anything. The Grover Shoe Factory disaster changed that. When 58 people died in Brockton on a Monday morning in March 1905, and another fatal boiler explosion struck a shoe factory in Lynn, Massachusetts the following year, the state could no longer pretend the problem was being managed. Massachusetts established a board of boiler rules, and in 1907 passed an act relating to the operation and inspection of steam boilers, the most stringent boiler safety legislation in the country. The law required design certification, material standards, periodic inspections by licensed engineers, and documentation of maintenance histories. It was the first time an American state had imposed comprehensive, enforceable rules on boiler construction and operation. But one state was not enough. ASME had been founded in 1880 in direct response to the epidemic of boiler explosions, but for 3 decades it had issued only voluntary guidelines. Manufacturers and railroad managers opposed mandatory regulation as needless government interference. It took the continued accumulation of bodies to overcome their objections. In 1911, ASME formed a Boiler Code Committee. In 1914, the first edition of the ASME Boiler and Pressure Vessel Code was published. It was 114 pages long, 5 inches by 8 inches, a single slim volume. The code established uniform rules for design, fabrication, materials and testing. States began adopting it. Ohio in 1911, others followed. A National Board of Boiler and Pressure Vessel Inspectors was created in 1919 to enforce consistent standards across state lines. It worked. The explosion rate dropped, not immediately and not uniformly, but the trajectory bent downward and stayed there. Boilers that met the code were stronger. Boilers that were inspected were caught before they failed. Boilers that were maintained lasted longer and failed less violently. The code grew. Today it fills 28 books and more than 16,000 pages. 49 of 50 states and all provinces of Canada have adopted sections of it by law. Over 25% of the companies accredited by ASME to manufacture pressure vessels are located outside the United States and Canada. The slim volume that started as a response to American factory workers dying in American factories now governs boiler safety across the industrialized world. But the boiler is still there. It is in every building heated by steam. It is in every power plant generating electricity from fossil fuels or nuclear fission. It is in every industrial process that requires heat under pressure. The fundamental physics have not changed. Water heated in a sealed vessel produces steam. Steam under pressure stores energy. If the vessel fails, the energy releases all at once. The ASME code, the Hartford inspections, the fusible plugs and safety valves and pressure gauges and water level indicators, all of them exist because for 100 years the machine was allowed to operate without rules, without oversight, and without anyone counting the dead. In the years after the Grover disaster, the city of Brockton held a funeral. A young boy walked at the head of the procession carrying David Rockwell's clarinet, draped in black crepe. Rockwell had been a musician. He had been an engineer with a first-class license and a dozen years of experience who understood the machine he was operating better than anyone else in the building. He had told his wife the boiler was being pushed beyond what it could handle. The factory's management told investigators that the amount of pressure on the boiler was not a matter in which factory officials interfered. They said the engineer took his orders from the Hartford Boiler Insurance Company. They said if he overworked the boiler, he did it without their knowledge. They said they did not even know why he used the old boiler that week instead of the newer one. Rockwell was dead. He could not respond. His wife had told them everything she knew. The crack was in the lap joint, hidden between two plates. The boiler had been inspected in December and found in apparent good condition. The technology to find that crack did not exist. A worker so dazed by the explosion that he walked away from the factory, applied for a job at another shoe factory across town, worked an entire shift, and went home that evening to find his family mourning him. 36 bodies, so badly burned they could never be identified, buried together beneath a stone that lists only their names, some of them only guesses. George Smith, who despite dying from his injuries managed to shove a woman within reach of rescuers. A 14-year-old boy named Harold Lawrence who pulled his own father out of the wreckage. A priest from St. Margaret's Church who ran into the burning building and lifted heavy floor joists off of trapped workers and went back in again until the building fell on him and he was carried out with injuries of his own. One boiler, one crack, one Monday morning. The same kind of boiler, with the same kind of crack in the same kind of factory, in every industrial city in the United States. The only thing that changed was who stood near it when it let go. Thanks for tuning in. For more stories about the machines that killed the people who worked with them, check the videos on screen. And if you want to see what we investigate next, subscribe.